Hello everybody, welcome to the Java course. This video is going to discuss interface, which is an important property contained in Java. If we want to create some more complex classes, you need an interface to help you combine with other classes in order to create a more complex class. So what does it mean by that? I can show you an example to illustrate the purpose of using interfaces. Suppose I have a clock class already, and I have created the constructor for that clock class. Also, I have created a toString method for a clock. And if we want to create an alarm clock instead of a simple clock, we actually need a component called alarm. And then when we combine the clock and the alarm, we can create an alarm clock. When we want to combine a clock and an alarm, we need to generate an alarm interface, and with this alarm interface, we can create the alarm clock class. Okay, that's the general idea. So when I have a clock, how can I create an alarm interface to help me create the alarm clock class finally? Let us see the alarm interface. Okay, an interface can only have public static final variables and public methods. This is an important property we need to remember. So by following this important rule, we can say something like this here. Suppose the alarm is having a certain type of sound, and the type of sound is called beep. I use a string reference called sound to store the string object whose content is beep. Okay, and for an alarm, I can also tell it to make some sound. Of course, the sound would simply come from the beep sound contained in the sound reference variable. So this is actually the end of the interface declaration. We don't create the methods by explicitly telling the contents of the method. We will make sound method more concrete when we really do the alarm clock class very soon. Let me save it. Okay. So let me go to the alarm clock class. Since the alarm clock class is going to combine the properties of both the clock class and the alarm interface, when we do so, I can set up the declaration as follows. Okay, the alarm clock is a subclass of the clock class, and when we want to create an alarm clock, we need to implement the alarm interface. So we use the keyword implement to indicate the interface that we are going to use. When we have this kind of declaration, we have to notice an important rule for this kind of interface usage. The extend keyword should come first, and then the implement keyword should come later. So we cannot exchange their positions. We have to follow the extend and implement order. Okay. So when I want to create an alarm clock, I need to create the constructor first. The constructor is quite easy because I can simply make use of the clock constructor. That is the constructor of the superclass of alarm clock. Okay, I use the super keyword to help me create the constructor for an alarm clock object. Since we implement the alarm interface, we have to define the make sound method from the alarm clock. From the alarm interface here. So when we create a class that implements an interface, we have to decide the implementation of the method mentioned in the interface. How can I make sound when I have an alarm clock? I simply print out the sound string, which is beep in my case. So when I want the alarm clock to make sound, it simply beeps. Okay, that's the idea of using the static variables from the interface in the implementation of the method mentioned in the interface. Okay. Of course, I can produce a method specific to the alarm clock. I can have a snooze functionality for my alarm clock. That means I can tell the alarm clock to be quiet for a few minutes. Okay, when I want an alarm clock to snooze, I simply tell it to mute for 5 minutes. That means it has to be quiet for 5 minutes. So that finishes the alarm clock class. Okay, so when I want to create an alarm clock object, I can go back to the driver class. How can I create an alarm clock object? Okay, that's a very simple object creation statement. I use the new keyword to create an alarm clock object, and here 4 means the hour and 56 means the minute. So the clock is now showing 4:56 as the time. Okay, AC1 is the reference variable to this object of alarm clock type, and I put the label type of this object as the same as the type used in the object creation. That means the data type for the AC1 is also alarm clock. Yes, I can tell AC1 to make sound. So let me try now. Yes, the word beep will be printed out because when I make sound, I simply follow the make sound method implemented in the alarm clock class. And the make sound method is simply printing out the sound static variable coming from the alarm interface. Okay. How about the snoozing action? Let me try now. Yes, I can tell the alarm clock object to mute for 5 seconds. That means that I can create a method specific to the alarm clock class, and then I tell the alarm clock to do such an action. So this is actually quite similar to what we did for creating a method specific to a subclass. Of course, alarm clock extends clock. So of course I can tell AC1, which is an alarm clock, to give the method coming from the toString method. When I run it, I will get the time for the alarm clock object. Okay, so that's the way we create the alarm clock class by combining the clock class with the alarm interface. Another important property of an interface is that an interface can be treated as a reference type. What does it mean by that? I can simply treat alarm as a type as follows. So here I create an alarm clock object, and then I label the reference variable as the alarm type. Since we rely on the alarm interface to create the alarm clock class, we can treat alarm as the something similar to the superclass of the alarm clock. So we can say that an alarm clock is a type of alarm. So in this logic, we can say that an alarm clock object can be upcast to the alarm interface type. Okay, so that's the meaning of being a reference type. Here it just means that an alarm clock is an alarm. So an alarm clock is simply a type of alarm. So that is similar to what we did for the subclass and superclass relationship. Okay. If I label A1 as an alarm, I can do something like this. I can tell A1 to make sound. What will I get? I will get the beep value coming from the static variable of the alarm interface. Okay. Why is it the case? Because we simply follow the actual data type when we want to make the method run for the alarm clock type. Okay. In my alarm clock class, I have a method called make sound. Here I just run this method when I tell the A1 object to do the operation which is inside the alarm clock class. So that is quite similar to what we did for the class implementation. We can also access the static variables when we have an object that is created from an interface. Why is it the case? Because the static variables are declared to be public, and it is the rule for Java that we can only declare static variables as public and final. So in this case, I can simply access this content directly. Let me run it. Okay, I can get the static variable by using the data type followed by a dot followed by the static variable, which is declared to be public. So that is quite similar to what we did for getting the content from a static variable. Since A1 is labeled to be an alarm type, in principle we cannot tell A1 to snooze, because the snooze method is a method specific to the alarm clock class, but not specific to the alarm interface. When we go back to the alarm interface, there is no such method as snooze. So in this case, we need to do the downcasting to make the labeled type of A1 to be alarm clock again. So that's my idea. I want to call the method specific to the alarm clock class from an alarm reference type. And that is the reason for the downcasting. The alarm interface does not contain the snooze method. When I want to snooze, I have to downcast the type back to the lower hierarchy. From the lower hierarchy, I can get the snooze method. So I can tell the A1 object to snooze when I have done the downcasting from alarm interface to alarm clock data type. So let me see the result. Yes, the snoozing action can be done after the downcasting. So that's why we can treat an interface as a reference type. And when we treat it as a reference type, the downcasting action is similar to what we did for handling the subclass and superclass relationship. We all know that we can create subclasses by inheriting some properties from a superclass. Can we actually create another interface that comes from a certain interface? Yes, we can do so. we can extend an interface from another interface. So in my example, I can create an electric alarm based on the alarm interface. So suppose this is the alarm interface. When I want to create an electric alarm, I can do something like this. I can create an interface called electronic alarm, which comes from the alarm interface. Of course, when we use the keyword extend, all the methods and the static variables are all inherited from the alarm interface. So it means that the sound string together with the make sound method are all inherited to the electronic alarm interface. So I don't need to say something more about them if I don't want to override them. So I can add some new contents to the electronic alarm interface. An electronic alarm simply plays an MP3 file when it wants to produce the alarm. So I need to indicate the MP3 file for this sound creation in the electronic alarm. For an electronic alarm, I can increase its volume by pressing a button or something like that. So these these two parts are something new to the electronic alarm interface. Okay, after I have created an electronic alarm, I can create an electronic alarm clock. How can I do that? I can create an electronic alarm clock by using the clock class together with the electronic alarm interface. So that's the implementation. I need to extend the clock class, this one, and then I want to implement the electronic alarm interface as well when I want to create an electronic alarm clock class. So I need the constructor. Again, I can use the super keyword. So that means the constructor from the clock class will be used in creating my electronic alarm clock class. Okay, because the electronic alarm has a method called increased volume, when I create a class based on the electronic alarm interface, I need to implement the increased volume method. So I do it now. Okay, when I increase the volume, the electronic alarm clock simply tells me that the sound is made louder already. Since it is an electronic alarm clock, we can expect that the mix sound method from the alarm clock can be a bit different from the alarm clock class. So that means I can override the method from the alarm clock. Now we have one more method to implement, which is this one, the mix sound method. Because I use the electronic alarm interface, I also need to implement the mix sound method because the electronic alarm interface has already inherited the method from the alarm interface. So when I want to make use of the electronic alarm interface, I also need to handle the method from the alarm interface. So how can I implement the mix sound method coming from the alarm interface? I can simply tell the electronic alarm clock to bell the ring. Okay, so these are the methods coming from the electronic alarm interface and the alarm interface respectively. Since the electronic alarm interface has also inherited the methods from the alarm interface, we have to implement the methods coming from the alarm interface as well when we create the electronic alarm clock class. So that's the basic idea. Let me save it, and let me go back to the driver class. Now the example is like that. My electronic alarm clock comes from the electronic alarm interface and the clock class. That is something we already performed. So I can create an electronic alarm clock object. Okay, this is the constructor coming from the electronic alarm clock class. Of course, when I want to create an electronic alarm clock, I make use of the constructor of the clock class. Okay, so EAC1 is the reference variable to this electronic alarm clock object, and the time for that clock is 8:21. Of course, I can tell EAC1 to make sound. Let me see the result. Yes, the bell is ringing. That means I'm going to run the make sound method from the electronic alarm clock class. Why is there a make sound method? Because it inherits from the alarm interface here. Okay. I can also tell the electronic alarm clock to increase its volume, which is a method here. Okay, let me run it. Yes, the sound is made louder. That means when I want to increase the volume, I can simply run the method from the electronic alarm clock class. Okay. Of course, I can access the instance variables. Sorry, the static variables from the electronic alarm interface, because it is declared to be public. Let me try now. Yes, I can get the sound file here. Why? Because it is declared to be public. I can use the interface static variable format to get the content of a certain static variable which is declared public. So after the discussion in this video, I hope you are able to understand the way we make use of the interfaces. For example, we need the keyword called interface to create an interface, and then we need to make use of a class together with an interface to create a more complex class. And we have to notice that we can create an interface based on a certain interface. Okay, that means we have a kind of inheritance for the interfaces. And after we have created some more complex interfaces, the methods from all the interfaces are implemented in the class that is using the interfaces together with the inherited interfaces. This is the end of the video. If you have any questions about my video, feel free to leave your comments on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.